So for this example, we are going to solve to make this function, a piecewise defined function, right? But we're going to solve to make it continuous. Okay, so if you read the thing, it says, find the value of a that makes f continuous everywhere. This is a function of x. The a is basically a parameter. We're going to have to solve for the number to stick into a that will make this whole thing a continuous function, right? Because on the left-hand side of 2, this is some parabola. On the right-hand side of 2, it's some cubic, and we want to make sure that those two are going to meet up. The only point I have to really worry about is the point at 2, because everywhere else, no matter what I put in for a, it's a parabola that's continuous. It's a cubic that's continuous, but because it's piecewise defined, I need to make them match up, okay? So in order to do this kind of problem, I want to take the limit from the left and the limit from the right and set them equal to each other. That'll have an a in it somewhere, and then I can solve for what a has to be. So let's do it. If I'm going to 2 from the left, that means I'm looking at values less than 2, so that's going to be this first part, right? So that's going to be the limit as x goes to 2 from the left of ax squared plus 2x. And of course, I put in 2, right? So then I'm going to get 4a plus 4, right? X goes to 2, a goes along for the ride. Same deal from the other side. Now my formula is different because I'm on the right-hand side of 2. So I've got this x cubed minus ax here. So now if I put in 2, I'm going to get 8 minus 2a. So for continuity, these two have to be the same, right? So let's do that over here. 4a plus 4 has to equal 8 minus 2a. 6a equals 4. A equals 4/6 or 2/3. So it was pretty easy to do it once we figured out what we were being asked to do. And in fact, if you like, you can then graph these and you'll see that they do meet up. All right, I'm not going to do it because that's the right answer, but they do meet up.